Recently, the first ever image of a supermassive black hole was taken in the giant elliptical galaxy of M87. This is a gargantuan black hole with the mass of 6.5 billion suns, an event horizon wider than our entire solar system. While the photo confirmed many things, such as the appearance of an accretion disk around the black hole, it also confirmed that a supermassive black hole does indeed exist in the center of M87. You might think this is an obvious statement, but how did we know that there was a supermassive black hole in the center of M87, and in every galaxy for that matter? First off, let's make it clear that the scientific explanations for why there are supermassive black holes in the center of galaxies is not 100% certain, but I'll provide a few of the most likely answers. We have discovered several supermassive black holes in the center of galaxies. Our own one in the Milky Way is called Sagittarius A, and has a mass of 2.6 million times our Sun. However, supermassive black holes are not the same kind as stellar black holes. Stellar black holes are the ones that form when a star with at least 5 times the mass of the Sun goes supernova. However, these black holes are extremely small, around 30 kilometers wide. When compared to the largest supermassive black hole, TON 618, which has a diameter of 390 billion kilometers, larger than the entire solar system, stellar black holes are practically insignificant. Another difference is that most supermassive black holes have an accretion disk, whereas stellar black holes do not. An accretion disk is gas and dust which is slowly consumed by the black hole it orbits. Strangely enough, a black hole cannot consume the mass instantly, because the mass assumes a slowly decaying orbit. Therefore, it takes some time to fall into the black hole, and this is why the accretion disk forms. This is why stellar black holes do not have accretion disks. There is not enough mass around them to create the disk, unlike the mass in the center of a galaxy. Hence, a supermassive black hole with an accretion disk is called a quasar. The strange thing about supermassive black holes is that the size of the black hole is directly proportional to the size of the galaxy. The bigger the galaxy, the bigger the supermassive black hole at its heart. These black holes were thought to have formed in the early universe, when the density of space was much greater. Gravity created stars of immense size, which in turn created black holes of equal magnitude. These first black holes swallowed all the matter in the surrounding area, which in turn increased their size further. Their violent feeding frenzy caused matter and radiation to be shot out in jets millions of light years long, and this is what is thought to have formed the stars that make up our galaxy. These long jets of matter and radiation condensed and slowly rotated around the supermassive black hole. Therefore, supermassive black holes must have come before galaxies and are key to their evolution. We owe our very existence to these supermassive black holes, and without them, our sun and planet would never have formed. Because nowadays we observe the galaxies to be of proportional size to their supermassive black hole, the best theory we have is that the black holes not just form, but drive the evolution of galaxies. However, we can divide supermassive black holes into 2 separate categories based on how the black hole feeds. Black holes that actively feed on the mass and energy around them are extremely dangerous and can produce violent bursts of radiation and energy. These are the first category and are said to be active galaxies, such as NGC 4258. From this image of the galaxy, you can see there is an extra set of red arms on top of the existing blue arms. Scientists now know that these extra arms were produced by one such radiation burst, and were able to work out that this is an active galaxy. The other type of black hole is a dormant and non-feeding one, such as Sagittarius A in the Milky Way. This kind is much more safe and does not produce the high levels of radiation as an active galaxy black hole. It is more friendly to life and allowed us to thrive on Earth without constant waves of lethal radiation that might occur in an active galaxy. However, if Sagittarius A was active, we wouldn't be able to survive and probably would never have existed. To create a galaxy, it is becoming clearer and clearer to scientists that a supermassive black hole is required. Without it, not a single galaxy would have formed. This is because black holes drive the evolution of galaxies, and shoot jets of material and energy required to create stars and the planets. Because Sagittarius A is now an inactive black hole, Life has thrived on this planet, and without this simple fact, we might not have existed. Anyway, thank you for watching, and I hope you enjoyed the video. Remember to leave a like and subscribe to the channel for more astronomy and cosmology content. Until next time, goodbye.